All right, in this video, we're gonna pick up where we left off with our review. With problem number 11, find the area of a parallelogram with a base of 12 and a height of 6. So my area formula is just base times height, and we have a parallelogram with a base of 12 and a height of 6. So area is just 12 times 6, and that's 72 centimeters squared. In problem number 12, we've got a triangle. Area is 1/2 base times height, and area is equal to, well, half of 12 times 8. 6 times 8 is 48, and that's meters squared. In 13, we have a circle. Area is pi r squared. My radius is 3.5, so area is pi times 3.5 squared. And take that to a calculator to get an approximation. And that's about 38.5. And no units, so I'm just going to put units squared. In 14, find the area of an equilateral triangle with an apothem of 3. Okay, so an equilateral triangle is going to have angles that are 60 degrees. And so if I go ahead and draw in, whoops, sorry, that's supposed to be straight. This is going to be a 30 degrees. So we have a 30, 60, 90. X root 3, and 2x. So I know across from my 30 is 3. That means across from the 60 is going to be 3 roots 3. Okay, so my area of a regular polygon is 1/2 the apothem times the perimeter. I know that my apothem is 3. I need to find my perimeter. Okay, so if this piece is 3 roots 3, I know the whole side is double this. So that's going to give me 6 roots 3. So that means my perimeter, if each side is 6 root 3 and I have 3 sides, that's going to give me 18 roots 3. So let's see, I'm going to take that to a calculator. So 1/2 times 3 times 18 square roots 3. That's going to give me an area of approximately 46.8, and don't have any units, so that's just units squared. In 15, the area of a parallelogram, I just like to draw pictures so I can see what I'm looking at. Whoops, didn't mean to erase that much, is 14.72 centimeters squared. The base is 6.4. Let's find the height. Area is base times height. So if this is 14.72 and the base is 6.4, find the height. All we have to do is divide both sides by the 6.4 to isolate the h. So h is going to be 14.72 divided by 6.4, 2.3 centimeters. In 16, find the area of the shaded region. Okay, so it looks like we've got a rectangle. So here's my plan. We're going to find the area of the rectangle, and we're going to subtract off the area of the circle, and we're going to subtract off the area of that trapezoid. And that should give me the remaining area, the shaded region. Okay, so the dimensions of the rectangle, area is length times width, and so this guy is 6 times 10, and so that's 60. The area of the circle is pi r squared, and so this guy is going to give me pi times 2 squared, or 4 pi. And the area of the trapezoid, okay, so this is one where we add the two bases, divide by 2 times the height. Your bases are always parallel, so these are your two bases. So this is going to be base 1 plus base 2 divided by 2 times the height, and the height runs perpendicular to the bases, so the height is 4. Okay, so 4 plus 2 is 6, divided by 2 is 3, times 4 is 12. All right, so I've got 60 minus 4 pi minus 12. If I take that to my calculator, that's going to give me approximately 35.4, and this is feet squared. Okay, let's take a look at number 17. We have a, looks like 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon. All right, so the area of a regular polygon is 1/2 the apothem times the perimeter. Okay, so the apothem runs perpendicular to a side, so my apothem is going to be 5. We need to find the perimeter, though. Okay, so let's see, what do we know? We know that the radius is, we don't know the radius, but we do know that, let's see, this guy would be 2.5. Oh no, how about it would just be 2? We're given that the side length is 4. Okay, now I know what I'm looking at. So this guy is 2. Oh, I don't even need that. All I need to do is my perimeter is, well, 8 times 4, which is 32. Man, I was making this harder than it looked. So my perimeter is 32. So it's just going to be 1/2 times 5 times 32. And take that to my calculator. How about 80? So my perimeter is 32. My area, and that's just units, my area is 80 units squared. And 18, let's see if I cannot make this harder than it looks. This is a hexagon, and I can find my perimeter. Perimeter is just going to be 6 sides, and each side is 6, so that's 36. The area, though, let's see. Let's go ahead and make a triangle. Each of the interior angles of a hexagon is 120. So that means if I cut this guy in half, this is a 60. This piece is going to be 3 because it is half of the side length, and the side length is 6 units. Okay, so the 3 is across from the 30, and so I've got a special right triangle. X, and then x root 3 and 2x. And the reason I need to do this is, well, because the apothem is this guy. It's across from the 60. So if I know that my x value is 3, this is going to be 3 roots 3. So the area is 1/2 the apothem times the perimeter, 1/2 3 roots 3 times 36. And so I'll take that to my calculator. And that's going to give me about 93.5. And this is units squared. This is just units. Okay, 19. Find the area of the shaded. Okay, so I got 2 circles. Here's my plan. Area of the big minus area of the small. And that will give me the shaded region. Area is pi r squared. And so this is pi times the entire radius here would be 9. 4 plus 5 gives me 9. So 9 squared minus the area of the small, pi times 4 squared. So 9 squared is 81. 4 squared is 16. If I subtract 81 minus 16, that's going to give me 65 pi. If I wanted to write that as a decimal, that's going to be approximately 204.2, and then this is units squared. In problem number 20, the area of a triangle is 216. If the height is 18, find the length of the base. Okay, so I know that the height is 18, area is 1/2 base times height. The area is given at 216. We need to find the base and the height at 18. So 1/2 times 18 is 9. If I divide both sides by 9, the base is going to be, well, 216 divided by 9, 24. Whatever unit, oh, inches. Okay, 21, composite figure. So it looks like we have a semicircle. Let's find out what that is. And then we have 2 triangles. So my total area will be the semicircle plus the area of the triangle. And I can just consider this one big triangle. I add those two together, I'll have my composite area. Okay, so semicircle is pi r squared divided by 2, and the area of a triangle is half base times height. So I can see that my radius is 8, so this is pi times 8 squared divided by 2, and the base of my triangle is the whole thing, and so that would be 16. And so half times 16 times 28, the height of the triangle is 28, and that's given. Okay, I'm just going to go straight to my calculator. So pi times 8 squared divided by 2, and then add that to half times 16 times 28, and that gives me approximately 324.5, and this is inches squared. I just went straight to my calculator. And in our last example, find the area of the shaded region. All right, well, I've got a large rectangle, and I'll just subtract out the area of the smaller rectangle. So the large rectangle has the dimensions 8 times 5, and so that's 40. And we know the area is just length times width. So 8 times 5, and that's 40. If I subtract off the area of the smaller rectangle, which has dimensions of 4 and 3, 4 times 3 is 12. So 40 minus 12, that gives me 28 units squared.